Hi everyone, my name is Vishaka Gupta. As Daniel already mentioned, I'm the co-founder and CEO of ApertureData. Today we want to focus our talk on data management, particularly on visual data, and I want to start by explaining why. Luis Remis, who is our co-founder and CTO, will demonstrate how in the second half of the talk. Estimates vary, but the storage needed by images or videos, or what we refer as visual data, collected by various types of cameras across numerous different industries, is expected to cross 80 zettabytes by 2025. It's naturally impossible for humans to pore over all this data and find relevant information. However, the advancements in machine learning and data science techniques, as you all are very well aware of, can help businesses across different domains extract very valuable insights. 4 years ago, back at Intel, when we started working on the design for an end-to-end visual cloud infrastructure to be used for machine learning on visual data, we spoke to machine learning researchers in academia and our company. At the beginning, we only ever heard compute, DevOps, and accuracy-related challenges that people envision in order to make machine learning a reality. Anytime we have data, we receive feedback to the effect of data access can currently be hidden behind because training takes so long, or image data sets can just be discarded after they've been used for training a particular model, or we're not really worried about terabytes of data yet. While all those challenges still remain present and are being actively addressed, in the last 2 years, the conversation has shifted to include data and data platform challenges. Now we hear comments and questions like, it's really hard to train on videos. Can I avoid fetching a gigabyte worth of video file just for 2-second interval that I need for training? Or can I store multiple annotations per frame, and the annotations may not just be boxes, they could be polygons? Then they start to get more and more into like, can I store the embeddings to restart my training from where I left off, or maybe use them to find similar items? Maybe I need to track and snapshot the subsets of data that I was using to personalize my machine learning model. And this by no means is a complete list. The challenges in data management are becoming more front and center, from the actual storage and access to validating correctness, removing outliers, fixing bias. Today, we want to focus on one of those, the management of this data itself. Let's first talk about why now, because we've been streaming image and video for a long time. The reason we need to rethink our strategy now is that we no longer just want to stream this data, but we want to analyze it more and more. So then a valid follow-up is, given the number of databases out there, why does visual data management deserve special discussion? Well, because images and videos can be individually large. Sometimes even one image can be gigabytes large and typically occur in large volume. So it's common to have millions of images or videos. Databases typically tend to support operations like sum, average, count, which kind of lose meaning in visual data. The equivalent in common operations, for example, would be pre-processing tasks like resize, crop, rotate, things like that. And they can be performed on images, video frames, or videos themselves. As common as these are across multiple applications, they can also be quite computationally expensive. So it's the complexity of operations that is quite unique in this case. Then visual data is also typically accompanied by a lot of metadata, because the metadata doesn't just contain information about the visual object itself, but also about the surrounding application, maybe annotations, maybe features describing the contents, and so on. So, going back to 4 years back when we did start looking at the problem, because we kind of anticipated some of these data challenges, and even to this day, we've realized that the lack of a database that understands visual data and doesn't just treat them as simple blobs manifests challenges over time. Engineers basically have to adapt and glue disparate systems, never designed for visual data or machine learning. They have to insert data in cloud storage buckets or some distributed file system. They have to store metadata in one among the plethora of database choices, like it could be relational, graph, key value, or sometimes even Excel, which eventually may not scale well. Pre-processing needed for display or further analytics is then spread across various components of the pipeline. So concocting such Frankenstein solutions and spreading the functionality across not only results in a maintenance nightmare, but also leads to suboptimal one-time results that don't necessarily evolve with the application. Beyond just the user impact, there is also a sizable business impact that results from a misuse or overuse of resources due to lack of a unified solution. There is a hiring cost due to needing more engineers or mismatching engineering skill set. And finally, but most importantly, there's a market cost associated with the delays that result from setting up infrastructure. All this causes businesses to potentially lose millions of dollars before even deploying machine learning in production. Aperture Data offers a unique database, ApertureDB, designed for visual data. Aperture Data treats visual objects as first-class citizens by offering native support for images, videos, and bounding boxes. Naturally, we also support pre-processing and augmentation operations on these objects. We manage the metadata information as a knowledge graph that offers improving insights as your application keeps enhancing this metadata over time. The metadata can be contextual or annotation-based. We enable visual searches by storing images or videos besides this contextual metadata. Since feature vectors can be used to describe contents in images or frames, we also offer the capability to index and search feature vectors, thus enabling similarity searches. And as a result of all these key features, you can actually save hundreds of hours of data platform engineering time, which eventually leads to faster analytics deployment. ApertureDB can layer on top of existing cloud or a distributed file system storage containing visual data and manage various assets. It can respond to queries from different machine learning frameworks, UI or visualization frontends, labeling frontends, and can be made part of an analytics pipeline. The queries can add, modify, or search visual data and metadata, annotations or embeddings. You can perform on-the-fly visual pre-processing and do more machine learning related tasks like data snapshots, like taking snapshots of the data that you were training on. Luis will demonstrate some of these features shortly. With its roots tracing back to Intel days, ApertureDB was always designed for scale and performance. This is visible from the performance gains demonstrated against a state-of-the-art system we set up to approximate a portion of the functionality offered by our database. So in this case, we stored metadata in MySQL, served the files over HTTP server, and we used OpenCV for processing the images. All of that against our system. So for visual queries on the Yahoo Flickr, the 100 million image and video data set, we were up to 35x faster depending on the query complexity and 15x faster on average. Since we can perform pre-processing on visual data near its storage location rather than transferring it to the client and then doing the processing, we often get an unexpected and welcome reduction in network usage, since the common case is typically transferring a high-resolution image from the storage or large video to a low-res or a low-resolution input to the neural network or for maybe thumbnail displays. ApertureDB is currently deployed at a stealth biotech AI customer. Based on the feedback that we've received after our successful pilot with them, they were able to save weeks of platform engineering time. They are already using our database with over 1 billion metadata entities and terabytes corresponding to 300 to 400 million images at this time. And they were able to create their machine learning pipeline with two or three fewer machine learning infrastructure engineers. So now I will switch over to, now Luis can take over for a demo of how our product works.
So what we're going to be doing in this demo is essentially going over some exploration of the COCO dataset. So the COCO dataset is a dataset that has a lot of information and a lot of a lot of information and a lot of metadata associated with multiple images. This is a data set that it's used for training ML models, including object detection and segmentation of images. And it's composed by roughly 120,000 images. Each of those images are curated, and the annotations have been very well curated, where we can find information about some of the bounding boxes, as you can see here, in the labels of each of the bounding boxes on all of their images, also some descriptions of what is the content of what's going on in the image. And what is very interesting is we have pixel level segmentation of each of the different objects of the image. So what we did for this is essentially load the entire data set into ApertureDB. So we can show you how very easily you can go and explore the data set and even retrieve the images, apply pre-processing operations, and interact with the data set, and even create subsets of the data set for running your specific training based on some constraints. And how easy that is, given that we support all the necessary infrastructure and interfaces to very easily access these images, these annotations, these segmentation masks, and essentially all the information on the data set. One thing we should notice is that even though this demo focused on the image functionality, we have similar functionality to user-defined entities and videos and feature vectors. And we actually have some demos that you can try on our website that I'm going to be showing you at the end. But this is just focused on images, even though we have a much richer set of functionalities. So the first thing we're going to be doing is tell you a little bit more about how we have structured our data set. Underneath, what we have is a graph structure. So we represent all the metadata following a property graph. And essentially for this specific data set, what we have the information model in the following way. We have a set of images. In this case, I'm showing just two images. And these two images have some specific properties. And each of those images are connected to, in the graph, to some of the bounding boxes that have some specific information about what's the content on the image. The bounding boxes have their own properties, which we can search and filter based on. And we also have the segmentation version, or the segmented pixel data information of each of the images, that it's also connected to the original image. So we're going to be, this is just to show you how the information is structured and how we can go about querying this information and retrieving the information and curate a new data set even if you want. So as part of the first exercise, and what we want to show you is how you interact. So with ApertureDB, essentially what we have here is a piece of Python code and a Python interface. So what we do here is import the VDMS module. VDMS is the name of the open source project. So the connector to ApertureDB is the same as the open source project. So we're going to be using that. And essentially what we do is go and create a connection to the database that it's running on the local host in this case. And we're ready to start writing queries. So all of our interface is based on JSON. So we have a set of commands, and you can put as many commands as you want and constitute a transaction. And the operation that you send, the query that you send, will be processed transactionally and operated transactionally on ApertureDB. In this particular case, what we're going to be doing is something very simple, is finding an image. And of course, we can apply some constraints. So we're going to filter those image, in this specific case, by one ID. I just want to retrieve a single image by this ID. And I also can specify a list of the properties associated with that image that are part of the image node, essentially in the graph. So we can just go ahead and run this query. So you can see I get an image of a horse. The image is returned as it is on the database. And together with that, I also get a piece of JSON that has all the information that I requested, like the date it was captured, the height, the width, the ID of the image, and some information that can be very easily parsed. So up to this point, all we did was filter an image by an ID. Now things get more interesting when, on top of just doing a retrieval of the image, we can apply some pre-processing operations. And all we have to do is add a set of operations as part of the interface. Again, this is just JSON. So what we can do here is apply the set of pre-processing operations, as many operations as we want, depending on what we need. And this is pretty common because when you use a data set like this for training, you usually have some pre-processing steps, either for data augmentation or because you need to resize the image or normalize the image so that it can be input to the neural network. So one case is you want to run this image through ResNet, and ResNet expects a 224 by 224 image. So instead of retrieving the original image and apply the pre-processing locally, you can make that operation happen on ApertureDB on the server side where the image is located, and just transmit the resized smaller version of that image into the client that is going to be running the processing on top of that. So maybe let me show you. Let's just run a single operation, which is a resize. So you can see we get the smaller version of the image, and we can also apply a rotate operation. For example, in this case, we're going to be doing a 90 degrees rotation, and we just change the parameters of the query, and we get the transform version of the image. So all of these very basic operations can be performed on the server side. And one thing we should note is that this is not this set of operations is not specific to this data set. Actually, what we have been paying particular attention is to put in our interface things or operations and interfaces that are application independent and that are useful for any application that relies on visual data. Essentially, all the basic building blocks that applications that rely on visual data need from a database. On top of that, we can do even more complicated, and we can increase the complexity of the queries that we want. One thing we can do, for example, is filter on many constraints. So in this particular case, given that the images have a width and a height, maybe I can go and filter by those two or as many properties as you want. So in this particular case, I say, okay, I want only those images. I want multiple images, but only those images that are larger than a certain size. So we can go and formulate a query that way. And in this case, we'll retrieve all the images that that fulfill with that operation. And another thing we can always do is essentially change the format. So the images are originally in JPEG because that's the way the data set, that's how the images on the data set come from. But suppose that you need PNG for whatever reason in your application, changing and doing a transcoding of that is just as simple as passing another parameter on your query, and you just run that and you will receive a PNG version. All of this operation of resizing or even transcoding happens on the server side. In this case, you will hardly notice any difference, but the image that we're returning here it's a PNG image. Maybe more importantly, for some applications to do the other way around, we have PNG that have less smaller compression rate when compared to JPEG. So if you have an original PNG, you might be interested in retrieving a JPEG version so that you use less bandwidth. You can do that very easily with our interface. So we can, having this background, we can go and do more interesting things. So if you remember, we have bounding boxes, and one of the properties of the bounding boxes indicate what's the percentage of the pixels with respect to the larger image. So if we look at this bounding box, this is telling us that this image, ID 34, with one specific ID, have a bounding box that contains a horse, and it's about 50% of the image. So we might go and filter images that way. So what we're going to be doing here is go and find all the bounding boxes where we have horses and essentially find the bounding box and retrieve the associated image. And we can do that for multiple bounding boxes, of course. So we're going to be doing finding a bounding box, filtering by the label of the category name, in this case horse, and then say, okay, I only want those images where the horse is at least 40% of the number of pixels that you have in the image. And we can go and find the images associated with those bounding boxes, and at the same time apply a resize operation. So we are able to express all these graph traversal and retrieval of an image and pre-processing operations by simply using the interface and without having to do much work or relying on multiple systems or multiple frameworks to do all this basic work. So of course, the graph traversal can be as complex as your operation requires. In this case, we just do a graph traversal of one level, essentially. But you can go as much as we want. Our interface allows you to essentially do as a deep graph traversal as your application needs. So we just go and run here, and we get all the images where we have horses that are where the image is larger than 40, where the amount of pixels of the horse occupies more than 40%. And we also can get the coordinates of the bounding boxes of the horses and all that information that can be very easily parsed because you get the response as a JSON object. So what we did here, and in order to go and do some more complex stuff, is we encapsulated the function that, or the query that I just showed you into this function, where we just pass the parameters. We just say, okay, the label and the percentage of the area, and we limit the number of results. Is just for demonstration purposes. What we can do here is go the other way around. We can find certain image and then go and find the bounding boxes associated with those images, and in order to retrieve that and draw the bounding boxes on top of the image. So this is just as easy as finding first the image based on an ID and then finding the bounding box associated with those images. And we can just go and run that query. And as you can see, from a single place, from ApertureDB, I can get both the images, apply whatever pre-processing operation, retrieve the bounding boxes, and get all the information ready in place for me to go and draw the bounding boxes there. And we can go one extra step and do the same query, but on top of retrieving the bounding boxes associated with the image, we can find the image that contains a segmentation that it's associated with the original image, so that we get all the bounding boxes and all the segmented versions. And when we go and run this query, we get something like this. We get the original image, all the bounding boxes associated with that, and a segmented version of that image here. In this particular case, we got 2 images as a result. So you can see the segmented versions of both. So the good thing about this is that it's very easy to go and explore this data set once you have a database that supports all the necessary interfaces that you need in order to retrieve all the metadata associated with the images themselves, and whatever pre-processing operations that you need on top of that. So one of the things that we did as well was based on this wrapper function that we showed you before, where we just go and change the label and specify what's the area, because we have that information model. Wrap around this and create a very simple function. I can even show you the code later, but the function is very small, and that will allow us to create custom data sets as a subset of the COCO data set. So again, I'm going to show you, this is the basic query where we just retrieve images of people where the area is at least 50%. We get some examples, but we can wrap that function, and that's what we did here in order to build a data set. So in this particular case, you might be interested to build a data set with only furniture, with the different metadata pieces of furniture that you have on your data set. And you can specify as many labels as you want. In this case, I want to retrieve the images that have dining table, bed, TV, or a couch. And I want 200 images of each of these classes. And one of the filtering that I can do is I want to make sure that at least 30% of that image is corresponds to each of the objects, so that if, say, I want to train that, I want to make sure that, for example, I'm going to be able to train on images on TVs that are large and not TVs that are very, very far away and really hard to see on the images. Now, ApertureDB is fully concurrent, so we can create this data set here, and we're going to create a new custom data set here. So we can in parallel go and retrieve all these different images. And in this particular case, the implementation that we did is retrieve in parallel each of the different tags that we have. So we can just go ahead and run this. And just by writing less than 50 lines of code, you can create a personalized data set. And it takes, in this particular case, 3 seconds to retrieve all those 800 images that are here in the new data set that we have created. And we have a train and test set of all the different categories, for example, bed, and we have all the images here. So we have all the images that, that constitutes our new data set that we can go and explore. So it is very easy to create these new data sets. The same way we can go and create one for animals, right? We just go and change the labels and it will be just as fast because everything will run in parallel in our database and retrieve all the images. Essentially, the other thing that we're working on is in just creating like a PyTorch data set or a TensorFlow data set by just changing the parameters of what data set is it's created, that will allow users to build new data sets that are ready in the PyTorch and TensorFlow format, that it's built upon going and querying ApertureDB. So we will just go and specify, say, I want to create a new PyTorch data set of images with these tags and with whatever properties, constraints that you want. And given that ApertureDB has all the necessary interfaces, it will go query the database and retrieve all the images that you want in the format that you want. So this is some of the things that you can do with by having a powerful interface, as ApertureDB does. So we have another set of demos that you can go and try. One of the demos is on medical imaging. We have a more complicated pipeline, and that works for medical imaging that we have done. In that particular case, the medical imaging graph, it's slightly more complicated because we have patients, we have visits, we have scans, and within the scans, we have multiple images. So you can model significantly much more complex data. In this particular case, we can go and run queries like, give me all the brain scans of patients over 80 years old that have received some specific drug treatment. So you can formulate that query and both retrieve all the metadata associated with the patients and retrieve images. And we have another functionality as well with respect to feature vectors that will allow you to work on surveillance applications or even smart retail or smart cities, that you can extract feature vectors from faces, for example, and we have interfaces that will allow you to insert those feature vectors, do similarity search, which is essentially finding similar faces, for example, and retrieve images associated with those similar faces. Those are all interfaces that we support, and you can go and try. So we are rolling out our new website. If you go to www.aperturedata.io, you can find the same demo that I just showed you and many more demos by going here to demo trial. And for example, if you want the demo that I just showed you, the CoCo data set, you just put your email here, and in 2 minutes, essentially this will instantiate the demo in Google Cloud, and within 2 minutes you will receive an email with the information access, so you can go and try. So go and try yourself. You have many different demos to go over that use different parts of the interface. And of course, we have all the documentation of the interface right here. So the last thing what I mentioned is that we are also hiring. So if you are interested in the project, or if you know anyone who might be interested in the project as well, just send us an email and we'll be happy to talk more. And of course, go and make use of the cloud trials that you have. And if you have further questions, there is also a contact form there, or just send us an email.